Okay. Hello all, I guess. Can everyone hear me fine? Okay. Well, I guess I'll go ahead. If you have any question during the live stream, don't hesitate to type it in the chat, and I guess I'll see it, but I'm not seeing anyone interacting in the chat, so I don't know if anyone is currently watching this. But what I want, let me present myself first. My name is Paul, and I have learned most of what I know in Rust today using Exrcism. And then I mentored quite a bit of it, of the Rust track in during the summer of 2021. And yeah, since then I haven't done much, but then I saw the V3 come out, and this year's activity 12 in 23, and then I've been invited to stream, so I wanted to try it, and yeah, I haven't prepared much, to be quite honest, but it's on purpose, partially at least, because what I wanted to try to focus on was to how would you say, yeah, to try the more beginner things, and specifically to try and the concept exercises I haven't done. I have done most of most of the exercises. I won't see them there, but I have completed quite a bit of it when I did them, and but not since I haven't done any since the V3 came out. So I wanted to use that as an opportunity to make some beginner content. So most of this stream will be me going through the concept exercises for Rust, and I'll use that as a way to sort of teach how a beginner should, I think, or a few tips and tricks, and of how to learn using Exrcism, how to learn Rust, and how both kind of fit together really nice. Let me just try a few things. If someone could just type a quick message in the chat to just see if I'm seeing it live or not, just to test if anyone is watching. Um, hmm. Okay, guess I continue on then. Okay, so we'll then begin with the most basic stuff. I'll complete. I think I might want to try it to do it the way I already always did it. Is to download the exercise, because then you have all the IDE stuff in there for you. So I maybe need to switch between windows all the time. So we'll see if that is viable or not. Okay. So yeah, I'm going to share on the screen. It's going to be much easier. Okay. Okay. So, so yes, the beginner stuff, obviously. So we have, from what I understand, to implement some very simple functions. And it's some basic set of stuff. So for any kind of beginner that is joining, um, a function, input, output, compilation in the middle. And so in Rust, it's defined as fn, the keyword, and the identifier, then in parentheses the arguments with mandatory types with the colon, and then an arrow and the return type blocks using curly braces. And here we're supposed to return 40 statically every time. And in Rust we can do return 40, or simply an expression, because it uses it implements some functionality of the functional paradigm. So you can just write 40 and it will return 40. And in this case, what you want in order to learn that is to use the official documentation, which is really extensive. So you can, so here is, you just follow this and you'll have the book, which will explain things. And then the Rust by example is really good. The Rust course is complimentary. It's really the very beginner stuff, but also some interesting things. And I personally learned pretty much everything using Rust by example, which I thought was really, really cool, because when you already have experience, you know things, you know what the concept, and then you just want to know how is it done in this language when you come to learn it. And so I use that as a first, but then the book will obviously go into much more details about and start with the beginner stuff. So use that, and also the for the the standard library, using /std, you will get pretty much everything you want about the standard library. The documentation is really extensive, so you can just search and you'll find anything you want. So using these official resources, you will get what you want. So function, how do you write a function? It's explained here, and so that's where you should start with the official documentation. So then you just have to follow the instructions of the exercise. So then it's just computing a difference here, because the total, it's just the remaining time is the current time, the total expected time minus, so we'll write this just to be clean, minus actual minus an oven, and I think that should be it. Exrcism uses a lot of unit tests in order to validate that your solution is somewhat correct. And then the real strong point of Exrcism is then that you can submit a solution for review by a mentor, and that's like I said, the strong point of it. But having unit tests is really the first step in having a good solution. Okay, then preparation time. Oops. So I guess it's just a multiplication. Oops. And then just the sum of it, I guess. Preparation time units for the number of layers plus remaining times minutes in oven of actual minutes in oven. And I guess that should be it. I'll be using Rust format all the way. It's the tool that automates the formatting of the code in Rust. It's the official tool, and it's really great, so you should use it. This is the Vim integration of it. And then cargo test. Oops. Yes, as a default, in Exrcism, all but one test are ignored, and they do not run. So you need to activate them manually. So and then run the tests again, and I am wrong. I guess I need to read instructions a bit closer. I don't say the test seem. I mean, 32. Oh, sorry. From the remaining minutes, we wanted the current time of minutes. I guess this should be it. Yes. And to validate that, it should be. Everything should match if I remember correctly. Wink. Aha. Okay, yes, I should read better. Sure. More concepts. Okay. So I guess I've done most of it. So we can do some enums, I guess, because floating point numbers are and integers are what most languages can manipulate. So nothing too fancy here. But I guess we'll start by the enums. Because some languages have it. Usually, the functional languages like Haskell or Camel, Elixir and the likes, Gleam also, and so they implement like an abstract data type for this. You should really, if you don't know at all what it is, you should read the chapter of the book on it, what it is, and then also the examples give you a good idea of how it's done. So my exercise. Okay. So for this one, we want to implement some logging. So the basic idea of an enumeration is a type that has only a listed amount of variants possible of values, and then what makes it a algebraic data type is that it can contain some information, some associated data to each variant. So you can have this, and you have the type, and that means info will contain a string attached to it. And what is really the strong point of it is that the compiler will tell you how you have a match in order to select what you will execute in, depending on the variant you receive, and that is done at execution. But then at compile time, the compiler will tell you if you have filtered through all of the possible variants, because you have different patterns, and it confirms that all patterns, that the patterns you wrote cover the whole value space, and that gives you a lot of control on your static verification of your code, so that you know if you have if you test for all cases or not. And it's used throughout Rust a lot. So you will see that with option. Maybe we'll get to that later on, but that is how it uses And that is how it makes the equivalent of the null pointer or the null value like in Java or none like in Python. But it gets rid of that, so there is no null in Rust. There is only options, and an option is a animation just like the one we're seeing here. So there's nothing major about it, and also for the exact same concept is used for error management. So there's another enum called result, and the whole error management is done through that. So yeah, option we'll see it later on. So here we're going to define all the three unit functions, and then we'll use it in the really API main log that will give the level and the message. So info is just info. Yeah. Okay, so it's really basic. I guess we can even, yeah. So in order to make this the easiest, we just use the format macro. Macros are like in C or C++, compile time code generation, and this one is implemented in the compiler directly, but it makes it so that using curly braces like in Python, you can define what you want in it. And in this case, you can just write info and message because message is a variable available there. So that is a syntax that was added relatively recently, and that is available just like in Rust, but only for println or format macros. That you can read in the book and the standard library as well. So for this, you will then we just want this, and we have pretty much the same thing here and here, with just warn an error, I guess. Yep. And then here we'll use the real power of animation is that we'll match on the level, and then just to show you what it's like. If I use log level info, then I call info on the message, and if I just do one case but not all, the compiler will warn me that it's not exhaustive. So that I just used one case, but oops, I made a mistake here. I'm not using warning and I'm not using error, and that is a mistake. So two solutions. The one we really want is to use all of them. To write all of them. Also, the default case is written like this in Rust, but we want to do all of them. So we'll have log level warning and then one message. So this is really basic, but it shows how to use it. Oops. And then everything should be good here. So then we can see that the compiler does not error anymore because it checked and proved that we have used all of the enums cases, and we have checked for all the enums cases. So we do not need a default case. And by the way, if we do that, it probably will do something that will tell us don't do it. Maybe different, like. Here it what? Oh yeah. Yeah. Oh yeah. Oh, it didn't. Oh, okay. It doesn't warn, but this is not executed. Is never executed. Okay, so with this we should be good. Whoops. Huh. Oh yeah. Oh yeah, I forgot the brackets. And we're good. And we are good to go. Done and done. So then we can go on struct, I guess, or I have to complete other. Oh yeah, I have to do some floating point numbers. Okay, so I guess this is yet another calculation, computation, exercise. Okay. So I guess we can write a function that gives off the success rate first, so that we can define the prediction rate per hour more easily. Per minute. Oh. Oh yeah, this is just a division, I guess. But we can just make it easier to understand, write another function that gives the success rate from the speed. And we have to take a byte in, but we have to output a float 64. So types in Rust, integer types are written using what most C programmers use today from the standard library. U for unsigned, then the size in bits, I for signed integers, and then again the size in bytes ranging from 8 to 128, and then for floating points F32 or F64, and that's it. Also in Rust there is no implicit conversions for these types, so we can probably see that here. Maybe conversion. Nope. But this is explained in the documentation. There is no implicit conversions for these types, so you have to say it just explicitly using the as keyword. So here we just have and we won't do any conjunction here, but in the next function. Just make some basic tests. Could it work? I don't remember exactly. Maybe we could use this and then 1 through 4. To implement it. Okay, yeah, that works. So with the match, you can specify intervals that will be matched for the integer you have instead of doing usual if it's greater than this and lower than this, then do this. So we can have it a more concise way of saying it. And here we should be unreachable because it's not unreachable, we just kind of panic, I guess. Panic is the way to error out and kill the program, basically. So 1 to 4 is 1 0. 5 to 8 is 0.9, and 9 to 10 is 0. And also, by the way, the syntax here is to denote a range. So when you use it in a for loop, it gives like all the numbers ranging from 9 through 10 included, or 1 through 4 included. And if you want to exclude which is pretty much the default, you could say you remove the equal sign, and that just goes from 1 to 3 included, and so 4 is excluded. So with this, it's never used. Okay. And then we have 221 times, so speed as f64. So that does the conversion of speed to a float. And then just coming in a few minutes. And then we multiply it by 221, and then and then the success rate, I guess, of the speed, and that should be good. Working items per minute, and then I don't know the difference. And just a division, I guess. But this time they want it as a U32, so I guess we have to run it about. So production rate per hour of speed, and then divided by 60, I guess. And all of that as a U32. Oops. No. Okay, let's try that. And that's a fail. Okay. Yeah, the exclamation point is the reserved syntax for macros. So it will always be whenever you can't call a macro without the exclamation point. If you do so, it will try to call it as a function, and at runtime basically, and vice versa. If you try to use a function with the exclamation point, it won't work. So yeah, it's exclusive things. And speed 0 does not like okay. If it is 0, it panics, which we don't want. I guess we can include 1, 0. Yeah, I guess that works. And that should work. Yep. Okay. Complete and kaboom. Okay, so then we have integers done. I did that, I guess, before, and structs we have 1 running. I haven't done yet. So this is a bit more interesting because this is the usual stuff you will be doing. Enumerations are good, but most of the time you use structs because product types, and it's pretty much the equivalent of a class. Just the type is exactly the same thing. Oops. Okay. So yeah, first, before you do that, you should take a look at the documentation for it. There's also the by examples, which gives off. Where am I now? So yeah, custom types, structures. Structures are, like I said here, pretty much like C, and like classes in C++ as well. Just in C++, the difference is that it's just visibility that changes from a struct to a class, the default one. But it's exactly the same idea, a product type with defined types. Also, the new is a convention, so it's a function like any other, but the only constructor that it really exists is using defining syntax. So you use the type. This is a shortcut to the current type, which you are implementing methods for, and then you write attribute and then value and comma, and that's it. And when you already have name and you don't want to type name, colon name, you just type name. So you have age, width, and that's it. So this is the only kind of constructor that ever exists in Rust, and this is just a convention for the default one, or the one pretty much the default one. Those are some accessors, I guess, like getters. In Rust, the convention is not to do this. It's a convention. Just write name. So self name as yes, that is correct. Then age, age, wait, nothing too fancy here. Set age again. So that age equals new age, and that is relatively easy to understand. I'll get into these things here that are explained, and pretty much the hardest thing to understand in Rust, and because it's pretty much the thing to the interesting thing about Rust, and when it's of its core functionality. So the documentation will get in much more detail than I can do right now. And yeah, so you should really read it before trying to manipulate it, because it's really tough at first. And self that weight, new weight. Okay, so here we define a structure with three fields, and in using this line, this is the way we say the methods or the associated functions we want for it. That is just a syntax, and then we make public sort of constructor for it, and getters are here, and then the setters. The main difference between the getters and the setters is that here there's only one ampersand, and then here there is a mute added. So just to make it really short, and that is not the whole story about it, but like I said, you should read the documentation about what are called the ownership and the borrowing functionalities of Rust. So that is an entire chapter by itself. But to put it really shortly, here there's no mute because it's not mutable. So it's pretty much a read-only access. And here it's mutable because you want read and write access. And basically the rule is that it's exclusive. You won't be able to do both at the same time, and time is in terms of code, and those are the lifetimes of references. So like I said, quite a bit of concepts here, but yeah, read that before. And here we want to have read and write access because we set a new value. This we don't need to have read and write access, so we're just reading. So a immutable reference is enough. Okay, and yeah, also forgot to say, but the self keyword is reserved, not like in Python. So this is a syntax, and self it will always check that the first argument I mean, if the first argument is called self, then it will be accessible through the dot notation of a method call, like we can see in the tests here. This is like in Java, Python, or C++ as well. You have the dot notation in order to access a method as well, just like an attribute. Um, okay, and yeah, so the self keyword makes it a method. Okay, that works. So this is really the basics of it. Yes. External crates, I guess we have to do it. No. Yeah, this is using cargo, so I won't get into that. What is necessary here? Destructuring, I guess. I'll skip that as well, and tuples as well, because it's not fundamental um, to Rust. The vec macro is a way to just write very simply a literal vector. A vector is the equivalent of the list type in Python, or array list in Java. So a growing array in memory, a contiguous memory. But it grows through reallocation every time you want to add, and implements it as a stack. Hence, vector as a stack. So destructuring, I guess. Oh yeah. Also, obviously, this gives a very simple introduction to what will be, what the exercise is about, the concept in itself. Okay. Yeah, usually 2 is a bit long, but I guess this is the exercise. I didn't shoot that. But it could be an age in I don't know, seconds, I guess also. Okay. Okay. So this is just way to write a tuple of, I guess we can see it here instead of using the tuples example. But like in Python, you just write parentheses, value, comma, value, and that denotes the type as well. So this is a tuple type. It's not a value here. It's really a type. And just like in a structure, it's a pure product type, so you can write. It doesn't have to be. How do you say that? Homogeneous. You can have different types, and it will work just fine. Then we want the modulo. Either that should do it, I guess. Yes. So those are the same exact computation notations than other, like Python again, or Java, if I remember correctly, for the modulo. And then one sort of strong point about it is that here the type is integer here as well. So the computation is about integers, because in Rust there is operator overload that you can implement yourself for your types. But in the compiler itself, there is the same semantic for native types. So the slash only performs the integer division, and here the modulo is the same, and it will return a successfully the same type. And so yeah, here they explain the concept of iterator. This is a concept that is shared by partially, or I mean, it's implemented in quite a few languages. So Python, Java as well, Go, and all the likes will implement it because it's really useful. The basic idea is that there is a next method that is implemented for the type, the concrete type, and every time you call it, it gives you a new value. And that is how for loops work in Rust. And here in order to really understand this syntax here, you have to understand first what is a trait. So it's basically an interface in object-oriented programming. And then this says I can accept a type that implements iterator. So I want an iterator, basically. And that is checked at compile time, not as runtime like in Java. This is really checked at compile time. I don't really understand. I guess I have to filter for only evens. Yeah, I guess so. So I enter that filter. But they forgot to add a bound for it. Um, So here the error is that we just write that we want any kind of type t as an input, and that is a parameter of the iterator trait bound, but we don't say that the type can be compared or divided by 2. And so it's because we don't say it's an integer. So we have to say that we have to add a trait bound like div. Oh no, not I guess. I don't remember that. So all of this is defined as traits. Oops. And all these all the, how do you say that, the operator overloading in Rust is done through traits, because that it's basically what you want. It's an interface, it's behavior, so you have a trait for it, and they're all under std ops module, and I'm just trying to remember the name of um, of the modulo trait, if it does even exist. Maybe I guess it's easier for bit and oh yeah. I'm not very sure how I'm supposed to. Or I can used with different types. I can sort of cheat, I guess. We're just actually expecting just a I16 and not receiving a concrete type, because this is just what I want. Oops. Oh no, okay. I think they just want all of the even positions, I guess. Yeah. I think that's just what they want. Okay, even positioned. Okay. Uh, um, how do you do that? So what we want is to select only every um, every only every once in a while. I don't really exactly remember if there is one that can do that for us. So there are a lot of methods in the trait that are given for us. Oh yeah, step by, yeah. I'm a bit rusty, I guess. So step by 2 should be what we want. I'll try that. Yeah, so that is good. Yeah, I mean, it's basically the same syntax. Just the requirement was I was confusing the requirement that I wanted to only keep the even numbers, but we aren't expecting numbers. We're expecting whatever we want. So we want even positioned items, and so that's why I was confused. But yeah, the syntax you're writing in TypeScript is could be exactly the same in Rust, except that it wouldn't try to do some really weird things. I guess in TypeScript there is type checking, so I was thinking about JavaScript, but yeah, it could be exactly the same, and it would be checked at compile time, just like in TypeScript, I guess. So then the Manhattan distance, forgot what it is exactly again. It might be oops, I don't know. Might be just the absolute value of the difference. Yeah. I guess it is just 0 then, compared to 0. I don't understand. Because from the origin. Okay, yeah. So this is just, yeah. Okay. So we have, if we apply the definition here with one of the points being the one we want, like x1, y1, our position here, and the other one 0, 0, then it just gives off x1, absolute value of x1 plus absolute value of y1, and so that's the only thing we're going to write. The neat thing in Rust is that native types are you use it pretty much like any other type, so they have their own methods. But what makes it different is because they don't receive by reference; they receive by value. Those methods, and so that make it just like any other function that will receive. Just like if you wrote this, in a math. In a sort of math module, but there is not much a math module in Rust because all functions are implemented by the compiler, but yeah, implemented as methods on the native types directly. So you have access to pretty much anything you want just using dot notation. So at first it can be a bit weird, but it's pretty useful actually. So we just have self.0, .x, and then the same for the other one. And also, yeah, for tuple access, there is syntax that is a bit surprising at first, using a dot notation as well, but it sort of makes sense because a tuple is used at compile time, not at runtime. So in terms of syntax, you want to be consistent with the rest of the semantics, then a dot kind of makes sense because a a pair of brackets is used as at runtime through addition on pointers and dereferencing, and that is not what is going on with a tuple. The offset is computed at runtime, so that's why it uses the dot notation. So surprising at first, but sort of it makes sense in the yeah. Okay, so with this we should be good. Cover tests, and we're good. Okay. And we're good to go. And then I guess we'll do option as a final exercise. Yeah, just to finish the stream on. So like I said previously, option is used to represent a possibly missing value. So in order to replace null, because null is not part of the type, and always being able to accept it is pretty much not what you want. You only want it sometimes, not all the time. And most of the time you forget to treat the case and just assume that it does not happen. Well, it can happen, and that is just a real nightmare in the end. So that's why Rust decided to get rid of that and to use animations, because the compiler can verify everything is good. Role-playing game. Oops. Okay. And again, like I said before, if you have any questions, don't hesitate to ask. Okay. 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 So now 0, and we return So the option enumeration has two variants. The first is some, and then the other is none. And they're written with parentheses for some, and some only takes one value, and none does not take any value. All of these are always available whenever you are, and they're inside that they're in the prelude, so they're always included in every code of every Rust code. So you don't have to write option some like you would have to for a regular animation. That if you didn't import, you can always import every variant in your global space, but I usually don't really want to for option. It's so often used that you you don't have the choice really. So in this case, we want to return a player that has health at 100, and the mana should be the same. And the mana, I guess the mana should be the same. There's a syntax in Rust that called the update syntax. Yeah. I'll get rid of the error just in a few seconds, but it just says take construct a new. So this is just a regular constructor. Take, use that for the health, but take all the remaining values from this value at the right of the two dots. And so if you have 15 attributes to your type, you just want to change one when you return a new value, then it's really useful because you don't have to write either a method for it because it's always repetitive, or to write every attribute remaining. Then we want give the level level 10. Then we have this, but with mana. Mana as well. And it's an option. And in the remaining case, we want yeah. So this should be good. And then cast a spell. Okay, so let's follow the instructions. if self that mana that is none. Now let's match on it actually. Here we have to damage the player by mana cost. I understood correctly. Yep. And then we return 0. Yep. And then let's use on the match a guard, I guess. So a guard is a test. It's equivalent as having the same match, but with a if in the block. But the compiler will also check for completion of, will try at least to check for completion of all the guards, and it will say if if it's just a checking for an integer lower than or higher than. I think if I remember correctly, it can deduce that everything is checked for, but sometimes maybe not. Some m, I guess. If m is equal to mana cost, then we'll have or yeah, let's follow it strictly. Just return 0 and we don't. Yeah, we don't do anything. And then if we have some m, we can just write this because this is the default case, which will be correct for what we want to test. And then we do. Oh, well, we have to write actually in order to get a binding. Self that mana equals some n minus mana cost and then appropriate amount of damage, I guess m, I don't know, or not, mana cost, I guess, or maybe level times mana cost, I don't know. How does it work? Ah, 2 times. Okay. Guess my syntax is wrong. Oh yeah. And yep. That should be good. Okay. So let's start with revive. Reviving a live player. Reviving. Oh yeah, I guess I shouldn't. Shouldn't do that, I guess. Oh, okay. Yeah. Self is definitely a shortcut for the current type. So you have here the type you're implementing methods for, and self is just a shortcut for that. So this is just at this point a syntactic sugar, but in the context of traits, when you define a trait, it's necessary, because if you want to define a trait like a method or a associated function that returns a new value of the type that is currently implementing the trait, then you have to say it in some way, and this is through the self keyword. So in a trait, it's really useful. It has a real use in the context of just a regular type you implement methods for. Then it's just sugar, but I personally like it because it's easier to write, and if you change the name of the structure, you just have it to you just have to change it in these places here, so when you use the self keyword, you use less places where you have to change the name, and it's always the same, so it's quicker to write. So that's why I use it. Oh, okay. Okay. Dead level 10 player. Oh, okay. I guess it's not that simple. Yeah, let's just do it in here actually. So mana is if self that level. Yes, that should be good. Oops. Ooh. Yeah. Okay. So yeah, in Rust implements some of the functional programming paradigm, and so that means that pretty much everything is an expression. So if like I've been using it since the beginning, but I guess it's more explicit here. If are just regular expressions like any other, so you just have to write none in order to say that the if expression is none, and then that makes it the return value of the function. And exactly the same here. You just say that it's pretty much what you want when you use a ternary operator in Python or Java or C or whatever, C sharp. I don't know if no, it's not in C, in maybe C++. But as in Rust, ifs are just regular expressions, and you don't need a ternary operator, and it's pretty useful. So yeah, I can just write directly in line, and it just works fine. Um, and then the cast. Cast large. It's not gonna cool. Oh, yeah. Oh, okay. I guess it should be a. Yeah, it panicked. Yeah, yeah. I didn't read the message. So yeah, if it mana cost is superior to the current health, then it's an underflow. So we have to do a subtracting add. What is it called again? Saturating sub. That's what I want. So there are also a number of integer different operators that do different kinds of things when you reach the bounds of the value space. So saturating means that it will stop at it, and wrapping it will do the usual underflow and wrap at to get. So there is that for the subtraction and the addition. So it's pretty useful. And with that, we should be good. All right. Okay, I guess I went a bit overboard with the time, so and I think we went through most of the interesting exercises of the concept exercises, the really basic ones. Um, all the rest I've already done them, and I guess they would be pretty much the same and not so focused on the core concepts of how you say of Rust. For this, I would actually recommend the Rustlings. So if I can show you, it's pretty much the same, but like an official repository of Rust, and it's just exercises purely locally, and it really does step you through the really basics, with taking really small steps. The Rust track in Exrcism is relatively small. There are a lot of exercises, but it's not there's not as much devotion to the track as other tracks. So yeah, maybe it's not as well done as other tracks. Um, yeah, and so yeah, I think both are really complementary, because when you get through the wrestlings, you only have the basics of it, and the exercises are interesting because you have you have algorithms to go through, actually. So with the basic exercises, you don't have much algorithmic things to do, but when you actually more the advanced ones, you have to think a bit through it, and also for the real advanced ones, you have to think about also how to organize your code and to engineer it, basically. So that's also a good thing to do. And so the wrestlings and the exercises are really complementary, I think. So yeah, I'm going to stop it here. If, like I said, if you have any question before I end the stream, um, don't hesitate to ask, and I'll be answering them. Okay, well, I guess I'll end it here. So thank you very much for your attention, and bye-bye.